All right, welcome to 5B, which is adding, subtracting, and multiplying radical expressions. So we'll do a lot of it today. Your directions are right up top, how to work these out. So first we're gonna, anytime you have addition or subtraction in the problem, you always have to simplify the radicals. And it really stands true at all times. If you ever see a radical you can simplify, you can do it at any point. Not always the fastest way to do stuff, but you can always do it. It's never wrong. So I'm gonna look at individual radicals, terms, and see if I can simplify them. So the square root of 27, can I simplify that? Sure. Square root of 27 as a square root, something of my perfect squares. The biggest one is 9. And square root of 9 is 3. 3 times 3 is 9. So that's my first term that comes down. That's simplified. My second term, I'm going to bring that subtraction down. Then my second term is 2, and the square root of 12 can be simplified into 4 is the biggest perfect square, and 3. So 2 comes down, square root of 4 is 2, and remember there's always multiplication. And then 2 times 2 is 4. Now, this is key. To be able to tell if they're like terms, we have to have the same. So now that's number one is done. Now we got to identify radicals with the same index and the same radicand. So the same index means the square roots are the same. They're both square roots. Good. So if one was a square root, one was a cube root, that would not work. And then radicand means what's underneath the square root. And they're both exactly the same. So I have 9 square roots of 3. And I'm subtracting 4 square roots of 3. So total we have 5 left square roots of 3. And that's our final answer. All right, number 4. Let's see if we can simplify anything. We have the square root of 28. We can simplify. The biggest perfect square is 4, actually. That's all. 4 times 7 is a prime number, so 4 is it. And square root of 4 is 2. Remember, when there's a coefficient in front of the radicand, or in front of the radical, there's always a multiplication. It's hidden. When it's not there, it always is. It's multiplication. And 10 times 2 is 20. Now our next term, I'm going to bring that plus down. And our next term is the cube root of negative 56. So I want to think about my cube roots. Is there a perfect cube that can divide out of negative 56? There is. And remember, cube roots can deal with negatives. The negatives can come out. So it's 8 and 7. And the cube root of negative 8 is negative 2. And the 7 will stay underneath. So it's really plus a negative is the same thing as a minus. So now we have those two. And our last term, 175. Biggest perfect square that can divide out of that is 25 and 7. Negative 4 times square root of 25 is 5. Square root of 7. And then negative 4 times 5 is negative 20. Square root of 7. All right, now let's look to see if we have any like terms. And it turns out we do. We have square root of 7, square root of 7. This one, the middle one, is a cube root, so those are not alike. And then we have 7 and 7. Cool. So only our first and last terms are alike. We have 20 of them, and we're subtracting 20. Well, that means they're gone. I had 20, spent 20. And what's left is a negative 2 cube root of 7. That's our final answer. All right, let's jump down to the bottom with multiplying. So what I showed you there with adding and subtracting is always going to hold true. Now with multiplying, we're going to multiply, make sure if you have coefficients, you multiply those together. So multiply outsides together, and then use the product rule. Product rule just means if you have two radicals that are exactly the same index, what you're going to do is you're going to put them together, or it's easiest if you put them together. So we're going to multiply underneath the radical. So I'm going to do number 9. So we multiply the outsides together first, 2 times 5. I'll just show this for this time. And then we'll multiply inside radicals. And it's a cube root because the indexes are the same. We can multiply inside. So 9 times negative 24. So you have 2 times 5 is 10. Cube root of 9 times negative 24. I don't know what that is off the top of my head. So let's 9 times 24 is 216. I know one of them is negative, so it'll be a negative 216. And now after we multiply, using our product rule and multiplying coefficients, we simplify the resulting radical. So I look at cube root of negative 216. That is a perfect cube. That is 6. All right, let's check that out just to make sure. Cube root is under the functions key. Go all the way down to the bottom, and there's a little nth root key. And you type a 3 in, now that's a cube root. You could type a 4 in, then it'd be a fourth root. Negative 216, and it is negative 6. Cool. So it times negative 6. 10 times negative 6 is negative 60. Done. That's as simple as it gets. On to the back. Actually, let's do one of these variables just to make sure. Let's do number 14. So number 14, multiply our coefficients. So it's 2 times 7 is 14. Multiply, they're both fourth roots, so we can multiply them together. So p squared times p to the third is p to the fifth. Add those exponents. You have q to the first and q to the 10th. It's q to the 11th. If you're not believing this, just think about what x times x is. That's x squared. So when you have like bases, you have to add exponents. So when I have p squared and p to the third, I have to add those exponents to get them together when you're multiplying like bases. After we multiply, then we simplify. So I have 14. We have p to the fifth, and it's a fourth root. So we have groups of 4, so we can take out one group, and there'll be one left over. Q to the 11th, how many groups of 4 can you take out? That's 2, so that's q squared. And that would be 8 total, so there'll be 3 left over. So it's q to the third. That's your final answer. All right, let's jump to multiplication. Multiplication, we have a monomial times a binomial. So we have to, you're distributing. So negative 10 times 5 square root of 5, so we'll multiply outside radicals. Well, there isn't an outside of the square root of 10, so there's a 1 there. 1 times 5 is 5. Square root of 10 times the square root of 5 is multiply the insides, use the product rule. That's 50. Minus square root of 10 times 2 square root of 2. Multiply the outsides, so that's 2. Multiply the insides, use the product rule. 10 times 2 is 20. After you multiply, you look to simplify. Square root of 50 simplifies into 25 and 2. Square root of 25 is 5. Square root of 2. 5 times 5 is 25, square root of 2. And I know I've said this in class. I want to say it again. If there's steps here that you can skip, go ahead and skip them. You don't have to show every single step. I'm just doing that so then hopefully I don't lose you. Square root of 20, the biggest perfect square is 4 times 5. And 4, the biggest, or square root of 4 is 2. And 2 times 2 is 4. The last step is to see, do we have like terms? We have square root of 2, we have square root of 5. Those are not the same, so no, we do not have like terms, so that is our final answer. So that's a monomial times a binomial. You just distribute that one time. Now in the binomials, some of you might have learned that you can just, it's called double distribution or FOIL. So you multiply those, and then you multiply here. That can get kind of confusing with radicals, so I'm going to show you how to do this with the box method. Up to you if you want to use it or not. It's the box method or Punnett square. We have 2 terms in our first binomial. We have a binomial in our first parentheses, 2 terms. So I had 2 columns. And I have a binomial in our second set of parentheses. So I'm going to have 2 rows. And now I'm going to multiply just like we've done in other units. 3 times 8 is 24. 3 times a negative 1 is negative 3. And then there'll be a square root of 10 that comes along with it. 8 times a negative 1 is negative 8. Square root of 10. Negative 1 times negative 1 is positive 1. And then 10 times 10 is 100. Anytime you get something and you're like, hey, wait, I know what that is, like square root of 100, you could just write 10 there if you want. 10 times 1 is 10. So in the bottom right box, that is ultimately, that's our next step, is to simplify each box. So that's going to end up being 10. Now I'm going to look at each individual box and see if I can simplify. Obviously, square root of 24, I cannot simplify. Square root of 10, that's 5 and 2, so no, nothing there. And nothing with the square root of 10. But now I can actually see that these diagonals here are like terms. So we have a negative 8 square root of 10, and I'm subtracting 3 more. That's a negative 11 square root of 10. And now actually, now that I'm looking, I have a whole number and a whole number. So 24 plus 10, and it's always addition. It's kind of neat. A teacher showed me this, like in the middle here, it kind of makes a plus. We're always adding these all together. So 24 plus 10 is 34. You can put it on the end like this, but I know some of you don't like when I do that because I said in one of the units not to do that after a radical, so you probably should put it at the beginning. So that's a positive 34. Just put it at the beginning. And we cannot put 34, we cannot do 34 minus 11 because we have to do multiplication before subtraction, and we're not going to multiply by, we're not actually doing the square root of 10 to multiply by 11, so we're not, that's as far as we're going to go. All right, those are all the problems I plan on doing for notes. Hopefully this helps you.